In this video, we're going to explain the power winding current creation. So here you can see we've got our 50 Hertz cable and our 60 Hertz cables. I'll take those out of the picture for right now because we don't need those. Now we're left with the actual power windings and the rotor. So right now it's shown in the maximum current position. You notice the rotor's cutting slots 10, 9, 8, 7, 6, 5, 4, 3 with one polarity, and it's also cutting slots 15, 16, 17, 18, 19, 20, 21, 22 with the south face, the other polarity of the rotor. So right now we have maximum current in both of the power coils. Now there's a little quirk going on here too. If we bring up the coil map, you notice that these four coils make up one phase and these four coils make up the other phase of the generator. What's peculiar though is that when this slot's being cut, it's cutting all three sets of coils here, all three pairs of coils. So it's not like you generate one alternation and you generate the other alternation in different coils. Both power coils get the same alternation, plus or minus. So in other words, when the red 3 is plus, and the blue 3 is also plus. In other words, they're not opposing voltages. They're not opposing induced currents. So that's something to keep in mind. That these two phases, although there's two separate phases, they're in phase, if you understand that. So what we're going to do now, we're at maximum current induced in the coils, in the power coils. Now we're going to rotate away from that. We'll select the rotor. I think we took the rotor. I'm going to go away from that, and you notice we just dropped slot 3. So we just lost current in slot 3. We also dropped 15. So rotate again. We just dropped 3 and 4, and we dropped 15 and 16. And we keep rotating, we keep dropping the current until something peculiar happens. Still dropping the current. But now look what's going to happen on the next step. On the next step, we shorted out 15 and 10. In other words, this north face is trying to put current into 15, so I was trying to put current into 10 so they cancel, so you get no current. So that cuts that current flow off from that winding. That winding drops out of the, as far as current flow is concerned. Same thing happens down here. The south face is trying to have current, pull current out of 3, it's also trying to pull it out of 22 at the same time. So that ends up being cancellation. So it drops off. If we rotate one more time, now we've got two windings that are dropped off. So we lost these two windings in the last two 15-degree increments. And that makes the trailing edge of the peak of the sine wave fall off more rapidly. Once again, this has to do with they want to have pole pitch to reduce harmonics. And who cares how fast this falls off that last 30 degrees. That's how this thing actually works. And then we keep rotating around. We're now building current again. And here we got maximum current on the other alternation. So the important thing to recall here is that as we start building current, the first two windings are ignored, and then those windings open up with the third winding and the fourth winding, fifth, sixth, seventh, and we have maximum current. Then as it's decaying, it decays just fine. It's dropping windings until right here, then it shorts out. 10. So it decays more rapidly here, with 10 and 20 being shorted. I should say opposing each other. So we're still, now we got two windings opposing each other. So basically we cut off we drop it back down to 0 quicker than would be normal. So how can this happen? Well, there's actually an easy explanation of this, believe it or not. It took me several months to figure this out. This face covers 1, 2, 3, covers 1, 2, 3, 4, 5, 6, 7 times 15. I'm sorry, it's covering 8 slots. It's covering that slot, 2, 3, 4, 5, 6, 7. It's covering 8 slots, so I made a mistake. It's 8 times 15 degrees per slot. Equals 120 degrees, and you double that, which is both faces. We're covering 240 degrees. Now, most generators, both faces only cover 180 degrees. So how is this going to work out? Well, the fact is we're dropping off 2 slots. There's 2 slot positions that we actually drop off. So if you drop off 30 times 2 is 60. Because of this weirdness here, the way these are both flowing against each other, we come back to the normal phase of 180 degrees. So this generator is unbelievable. But I think it does work exactly like this. So we're actually getting a 280 degree per phase of sine wave, but yet we're traveling through 240 degrees of slot rotation. Like I say, this thing's amazing. So I just want to clarify that before we even get started with these power generating currents. Because of the previous lesson which demonstrated how the exciter windings generate current, we don't need to do that detail on this one. Here's the phase windings we talked about. So basically we're going to generate current in the same direction because this slot 18 is tied back to slot 6. And the same thing's true for both windings, both power windings, and it's also true for the battery charger windings. Now, the battery charger winding is a little bit different because we have a black one which is common between the two. So if we ground this and we get half the voltage to ground to the battery terminal, which is blue 250. Then we also get the opposite party over here on the blue 250 with tape. So this, if you don't ground this, then you take a bridge rectifier and go between these 2 points, and you'll get double the voltage. So what comes out depends on what you do with this black one. I just want to point that out also. So we're not going to walk you through every little step of every little slot, how it generates current. It's the same concept that was demonstrated in the exciter winding video. So let's get back to where we were. Once again, just like in the exciter windings, these are integrated stepped currents through these windings due to the inductance of the windings. So it gives you a sinusoidal waveform. And it just happens it's 2 alternations, each one's 180 degrees, gives you 360 degrees from one sine wave. And that's exactly what we should get. This little funky stuff up here is what makes all that happen with this particular pole pitch for the windings. Notice each winding has a different pole pitch, and that also helps with harmonics. So I'm not going to go into any more detail on this, how this generates current. But later we'll be talking about these power cables, these 2 guys, and why they're attached at those points. That's another lesson in itself. So this concludes this lesson. Hopefully it was useful.